So cohort space number, super fancy cohort you're building in there.
Well, give it the real meaning. The idea is that you're going to think of a population that you want to define and study, and with the intent that we will also say later define an outcome that you'd like to understand in that population. Okay? So definitely you want to number this so that everybody can keep their stuff separate. And later we can actually review some of them and take a look at how it was performed. Not to put anybody on the spot, but we are trying to get through a lot of different cases and make sure you guys are exercising the tool.
So because this is a shared platform that is running on the same server, all of your cohorts are visible to us. And so you can if you build a cohort, we can then pull it up and review it on the screen and actually say and critique it and learn from it. So would you like to pick, as a group, pick some sort of a clinical phenotype, or would you like us to just think about it and give it to you?
Like when you guys came to the class, did you have a research focus?
Yeah.
You do, right? Why don't we take like 3 or 4 suggestions from the community here, and we can just work on it. You can each decide which one of those sounds like you'd want to do some research on it. What's that? Call Jenna? Jenna can't save us all. All right, so let's write down a couple of stuff, and they can put in the phrase of like the incidence of such and such among a group of people, like the group, you know. Amputation among diabetics, you know, like go ahead and call out some ideas. Go ahead.
Go ahead.
Switch it, the incidence of therapy switching in hemophilia or lymphoma patients.
Incidence of therapy switching among hemophilia patients.
Or lymphoma, no.
Lymphoma patients. Okay. So therapy switching, what does that mean in lymphoma patients?
So like switching line of treatment from therapy 1 to therapy 2.
Okay. So do you have in your mind what the list of these therapies are?
Yes, I can find them quickly.
Right.
At least the top 3 or 4.
That's fine. Amongst those 4, how does it work? Okay.
Cool. What is the target and what is the outcome in this?
Oh, that's a good question.
I think in this case he's asking about switching, so we could actually maybe apply the pathways capability.
Yeah.
And at which point you're going to have to describe still the period of time for a group of people that you want to investigate switches or transitions of treatment, okay? That's what you have to have in your mind.
Right.
So what is this population? You said lymphoma, right?
Mm-hmm.
People, first diagnosis of lymphoma?
Yep.
All right. Let's say we follow them for a year.
At least.
Okay.
At least 6 months, I would imagine.
Okay.
But a year max. Yeah.
Well, the max should be, we could say for all time. That's fine too, until end of observation.
I think a year is plenty.
Okay. And then you would have to just define what you are considering a treatment.
Yeah,
and then
naive treatment, right? So no previous treatment for same indication preceding 6 months.
You could find first treatment of each, and then as we go through the tool, it'll basically show you, okay, starting here, like so percentage of people started here, and that percentage of people went on to this.
Yeah.
Or something like that, right?
That's the kind of study that
Excellent. So, and this sounds more like, to just give it a little frame of like what kind of studies, this sounds like a characterization study, because you're not necessarily trying to get the incidence rate or of comparative effectiveness. You're actually kind of trying to just understand the population. You want to know what is it about this population, and how, is there a standard of care for this, or does it look like it's all over the board? Does it look like people go through many levels, or do they go and stop? And you'd like to kind of understand that type of characteristics.
Yeah, kind of a hypothesis, but
All right.
I'd like to validate that.
All right. Okay. Perfect. All right. So that'll be one thing. And if you could actually, if there's like people that like that idea, dividing and conquering would be, you have to come up with a specification of what that population is, and the follow-up time is just like you said, a year or 2. And then individually, you have to define the cohort of like initiating a treatment. and then of the number of treatments that you would like to understand the transitions between. And you go ahead and do that, and like that's a good way to divide and conquer. Like one person says, I'll make the new user cohort of regimen 1, and I'll make the new user cohort of regimen 2, you know? You come up with like 5 cohorts, and we'll just put it through the tool and see what we get out of it, all right? All right, so that's one thing we can be doing. Anybody else got an idea? All right, yeah, come together.
Okay, maybe
What were you talking about?
My idea was looking at comparing the risk of stroke after 2 different drugs, aflibercept or ranibizumab, in patients who have macular degeneration.
All right, patients. So
patients are patients with
macular degeneration is our target.
Yeah, we get either aflibercept or ranibizumab.
Okay.
So it's patients with macular degeneration.
Yep.
There's one cohort that had one drug,
Yep.
another cohort that had another drug,
Yep.
and you're looking for a
Outcome
second
is
outcome.
stroke.
What was the outcome?
Ischemic stroke.
Ischemic stroke.
Perfect. We can do that. So in this case, we're talking 3 cohorts. Both cohorts of the treatment group have a prior condition, prior diagnosis, to say this right. But then the start date of this cohort will be the initiation of the treatment, and how long will they be followed?
Well, I know that it happens quite quickly if it happens, so we'll say 3 months.
3 months.
Okay. Within the first 3 months, do they have a stroke?
And what was the 2 drugs now?
One was called aflibercept,
How do you spell it?
AFLI,
A-F-L-I
BER,
B-E-R
CEPT.
Now, is this an international drug? Or is
Yeah,
it
so
something-
that's the ingredient.
All right.
Yeah, and ranibizumab, RAN,
R-A-N, okay.
IB,
I-B.
ZU-MAP.
Right.
Okay.
Okay.
All right. Team up with Nicole.
Anybody interested in that question? Team up with Nicole.
And they're really gross if they're injecting it straight.
All right, no pictures. How about you guys? Do you have any particular thing that you're interested in as far as like a study question? Okay.
My outcome seems to go more focused on
Yes. So with prediction problems, it's a matter of defining what your baseline population wants to look at, and then what is the outcome. Also, you know the results. Well, you're not going to look for women between 18 and 35. What is this sort of event that you want to say? All right, guys. So we're having a error in our environment, in the cohort environment. So, sorry. So anyway, if you're doing anything, keep trying. But I'll be working with the IT support. And if that all fails, if you guys are like just doing research right now and thinking out the problem, I'm happy to like work on it through our internal environment. If you guys have, we can just go through. If you guys actually have things that you're doing, I can do the typing for you on your thing, you know what I mean? All right, so we'll do this one right here first. You guys keep working and then we'll move around and we'll try to like recreate what you guys want done. All right, so.
The first one was Rituximab.
Okay, so I'm gonna make a cohort definition for Rituximab, okay?
And then we did a new cohort. Or no, actually, we started with the concept.
No, you first did one cohort, then you go to concept set, and then
So what user were you, by the way, just so I can keep it organized? And this will be exposure to something?
I called it switching.
Yeah, but this is the cohort for one of the drugs, right? Rituximab? Okay.
You can do Ritux, R-I-T-U-X.
Is that all right? Rituximab? So we'll go to concept sets, we'll make a new concept set, and we will now search for Rituximab. not good. The workspace environment crashed. I'm getting like hard failures from the web server, so it's over. So what I'm doing is I'm just gonna do it. They're gonna tell me what to do. So here's rituximab. We want the ingredient. Yeah, we want that guy. That's the standard concept. Rituximab.
Yeah, we just selected in the vocabulary section RH norm and everything that was there, and then picked it.
Don't need to do that. That's okay. This is learning. We are allowed to pick all the descendants of the ingredient, and we'll get everything automatically. Yes, that covers all the branded forms, all the formulations. All right, so to show you how that looks, well, all those J codes were mapped over to drug exposure records.
J codes are non-standard, they're mapped to standard, so during the ETL process, they would put the J codes in the drug source concept ID, and the drug concept ID would have.
We still are.
Which means that it's in the constellation, just by using ingredient.
You can't find
drug source ID.
this concept now in
Because of the mapping that's done by the vocabulary,
cannot
you just
find
pick the ingredient,
Atlas.
everything else comes through.
Yeah, this searching is broken. Like the environment crashed. So what you guys should do is just write down the concepts using Athena. It's a good idea. Write down the concepts of the code list that you want to make, and we'll do it together on the screen. Okay? All right. Sorry about that. So, do we want individual exposures of this or just the first time use? The question is when you show your treatment progression, are you only going to look for first time uses? Okay. So, we'll say first time. First. And we don't care about prior exposure. Let's also say that you were talking about overlap and continuous exposure, right? So you want to know when it started and stopped for that first time use, right? So you're going to want that. So we're going to say continuous drug exposure to that drug. We'll say 30 days. And maybe a 7-day. We don't have to put, basically it's a question of after I figured out my last exposure, do I want to add any extra time for like some surveillance window, or just no, just take from the start to the end of the exposures? It just means that even after it's done, you're going to consider yourself under the effect of the drug even after the drug exposure ended. Okay. All right, so this is the distance between each individual exposure. 30 days sound good? Okay. It's not going to make them longer, it's just going to bring them together. Okay, so that's 30's good enough. 30's good enough. Yeah. It's generous, but it's not ridiculous. All right. So let's do the second one. I'm going to copy this cohort definition, if everybody want to watch. I'm going to copy the cohort, and I'm just going to change the code. All right? So I'm copying this cohort definition. I'm going to rename this to the second drug, Darzalex. Okay? And now I'm going to edit this concept set, and I'm going to rename it to Darzalex. And I'm going to remove this guy, and I'm going to search for Darzalex. Oh, that's a brand name? No problem. I'll show you how to find out. At that point, you would say, okay, instead of trying to find a continuous exposure, I'm going to say that the duration of the exposure is, I'm going to tell it what that is. Yeah, and then you can just chain all those events together. Oh, sorry about that. Oh, I'm sorry. Oh, sorry about that. 1 second, guys. All right, cool. All right, so Darzalex, here we go, right? So we have we have this guy. I just want to look for like from the RX norm. Right, so here's a branded drug and you don't know what the ingredient is, right? It's like, what is it? So we can click on it and take a look at, I think, the hierarchy. Now, let's look at related concepts and let's just look for ingredient. There it is. That's what it is. So related concepts finds all the hierarchy and mapped. It'll show you like NDCs. This view of related concepts looks at all these connections. But we want the connection that leads to an ingredient. That's the one. All right, got it. So we add it, we go back to here, we give its descendants, and we're done.
Okay, so the descendants would pull back in all permutations or uses of that ingredient.
Yes.
What are those cases where you have dual ingredients, like what, like two ingredients?
Combos will find a combo. And if
NDC code has combos that have a single NDC code.
the combo is the single NDC, but it's like a pill with two things in it. So it'll show up under the one hierarchy and the other. And if you said I didn't want the combo, then you have to find the combo concept that says this is the combo, and you exclude all combos of that thing. That way it won't be in the code list. So all we're doing here is creating the code list. And I want to check one thing because I want to make sure I said descendants in the last concept set we made. So user 30, this guy, concept sets. I just want to make sure I did not, right? Bring it in. Okay, so we want to do the next one. Let's do like 2 or 3 more, and then one more? No problem. All right, we'll do one more. Alrighty. How's that spelled? M-I-B? Is it R-E-V-L-I-M-I-D? Okay. All right.
As all these new products are coming to market, this particular therapeutic area is actually 5 new profiles. Just switching therapies. There's going to be dramatic changes in like best practice between last year and this year. So it's going to be a space that I'm going to be looking over and over to see what's going on. And I think the best practice across the 5 new novel molecules is emerging. You want to know like what's getting the most from the performance, what's going to get pulled through it, and what amount of time, and how, the impact of the research would be, how is that function as a sequence of the FDA? Because it just happens to be one of them gets through first, and it's going to have the greatest initial uptake, but it could be displaced because the next molecule succeeding it is better. Right? So that's not going to come out for a couple hours.
Oh, thank you. All right, one more. All right, now I need to know your target population. Oh, is this the lymphoma? All right, so anybody suffering from lymphoma that doesn't have another cancer, no problem. So basically, we need 2 codes then. We need the lymphomas and then everything but lymphomas from a cancer perspective. So what we're going to do is I'll just make, I need to make a new cohort definition. Something like that. Lymphoma. 30, right? Okay. So just off the bat, I'm just going to define, we know we want these 2 concept sets, and we're going to try to figure out how to build it. So we know we're going to need a new concept set for lymphoma. And then we have cancers without lymphoma. The idea here is that we just want to find the people that are suffering from a lymphoma, but not other cancers, just that, right? So that's why what we're going to say is find me the event of the first diagnosis of lymphoma, and then no other cancers also, no other cancers. Okay. And we can even say no other cancers before and after. I know it sounds cheating, but we can say we're trying to look for people that don't develop the other cancers so that you can have a treatment pathway that is focused on just the people. Because you're imagining if they develop cancers, things are going to change in their treatment. So let's just find out that, right? Yeah. All right. So initial event is going to be the diagnosis of lymphoma. First time. And we'll just say there's, how much time prior do you want? The year? Yeah. Okay. Now, we need an exclusion criteria of no other cancers.
The problem is that there's fine to be given for concept or cohort.
Come on. You've been taking this class all day. You know the difference between a codeless and a cohort. So we define the codes that are, I still need to say where do these codes have to appear in data. So the cohort is saying, where should I find those codes? So we're saying we should find no other cancers prior to the first diagnosis of lymphoma. Or we could go further and say no other cancers at all. We can also say like before and after, like you will not find cancer in this whole record. Normally you wouldn't do that with like a study replication because you can't see into the future, but for us we'll say we only want to know what happened among people that had no other cancers, just the lymphoma, and that's it. And that's not a violation of any principle. We're just trying to focus, we want to understand those people that didn't develop the cancers, what was their treatment progression? That's all we want to know. So no other cancer, we're going to add a condition, occurrence, and we're going to say no, this is how you say did not happen. Exactly 0 occurrences of the cancers without lymphoma, all time before and all time after. So you're out. It has not been defined, but I haven't defined it, but it exists. I'm referring to it. Yeah. No, it's empty. So we're getting there, because I'm trying to do the easy stuff first. Do we all agree on logic? We're basically saying first lymphoma and then no other cancer anytime. Yes, exactly.
Question, can we create a concept set which is a mix of different domains?
Yes.
We can create that, but how can we, when we use this?
No, but where you use it, you have to pick the domain you're going to look for. So the domain that's queried is not based on the domain of concepts that are in it. That's why you can make a concept set with multiple domains, but you have to use the concept set to search those domains. So if it's easier conceptually to say this is a concept set that uses drugs and procedures and conditions, fine. Call it the collection of codes for something. But then if you're going to use it, you got to select it from conditions. You got to do all of it. All right. So this is the hard part. Cancers, and then cancers without lymphoma, and then cancers without lymphoma. All right, so let's see how easy this is going to be. All right, so I'm going to save this. We'll go here, and so let's just start with lymphoma. So I clicked it so it's active, and I went to the search screen. So you see how it has up here, lymphoma is active. I'm going to zoom in a little. Okay. All right, let's see what kind of things we get with lymphoma. Here we go. All right, non-Hodgkin's, Hodgkin's lymphoma. Would you consider Hodgkin's and non-Hodgkin's the same? I mean, are they lymphoma? All right, so here's lymphoma. All right, so we're getting a lot of different vocabularies. We're only looking at conditions. So first we could look at the domain condition. That narrows it down to 15,000. Oh God. How about we a clinical finding? There we go. Malignant lymphoma. Is that good? Sorry? So let's take a look at what malignant lymphoma rolls up to. this is just querying vocabularies at this point, but when we run it, we'll do it on like an Optum Clinformatics, like an Optum or Truven, you know. We have some choices. But all right, we'll start with this, malignant lymphoma. What's strange to me is, Rima, is that I was hoping to see like general cancer as a parent. So I'm seeing these guys right here. So malignant tumor of lymphoid like I see this guy right here. Yeah. I'm going to pick this guy. Oh, look. And then we have malignant neoplastic disease. Perfect. Here's my recommendation. Malignant tumor of lymphoid, hemopactic, and related tissue. Is that okay for lymphomas? All right, so let's use that. But I'm also going to add malignant neoplastic disease as the parent, and basically I'm going to exclude everything under that parent except that. All right, so here we go. So RC and DRC is, I know I missed it. No, actually, I think it'll be here. Yeah, here we go. So you can set up Atlas to look at summary statistics about how many records you have in your CDM. And what this helps you guide you to is, should we be arguing about a concept that doesn't have any presence in the data? And so this is telling you that there are 2 million records that were coded directly to malignant lymphoma. And then there's 7 million records that were some descendant of this concept. It's just telling you, you know, it happens. It's there. All right, so what we wanted to do with this particular one, this is lymphoma, right? That's too bad. This is good. I'd rather this would be our cancers without lymphoma. That's fine. So let me go to concept set. Okay, so I'm going to rename this to, damn it. Hold on. I wish this was my other one, but we already put it in the cohort, so if I switch it, it's annoying. All right, it's fine. I'm just gonna do this again. Let's do it again. Let's do it again. Fuck. I haven't done the other one yet. I wanted to do this one first. Oh, yeah? Oh, sorry. So I picked cancers without lymphoma so that it was selected. I didn't do the shopping cart yet, but I selected that one so it was the active concept set, and then I clicked on the search so that I could start adding stuff to that concept set. My problem is that I was on the lymphoma concept set when I started adding stuff to it, and I didn't want all the cancer concepts in there. So I'm doing it again. I'm doing the search again to add it to the other group. Because it's not that easy to just copy stuff. So we got this lymphoma. How did we do this? I'm doing the same thing again. Here we go, malignant lymphoma. We looked at that and we saw that, yeah, hold on. What happened? I feel like something's going on. Sorry. I hope it's not our network again. It was working so well just 2 seconds ago. Here we go. Here we go. Malignant lymphoma. There we go. And then we looked at the hierarchy and we saw that this guy, we like this guy. So that will be, and then, yeah. And the one we really want is malignant neoplastic disease. All right, so. Yes. And now, what do I want to do with these two concepts? I want all of the cancers or malignant neoplastic diseases, but I want to not bring in the ones that are lymphoid and their descendants. All right. So if you think of it as a tree, I basically pruned off one corner of it, which is yeah, it's gone. All right. So, and look, 42,000 included concepts is there's a lot of codes for cancer. All right. So we'll save that. Now, on the lymphoma side, it was just simply malignant tumor of lymphoid, blah, blah, right? So we just want descendants of this, and we don't care about these two guys. So to remove this, you just click that, and then you click that. Okay. Simple cohort. Okay. And now everything is good to go, right? Let's just make sure, right? Cancers without. Anytime, if you had one of those other cancers, it's out. Okay. All right, let's save it. Did we actually say newly diagnosed? Yes, exactly. Okay. So what I want to do is I want to generate this on like Optum.
So on your server, you have, and which set of data sources do you have like OHDSI controllers binding to OMOP CDM versions of all these files?
Yeah. Yep.
One atlas can point to multiple different data sets.
Absolutely. And the reason why that is because you want to define your cohort once, not one time per CDM that you have. So the whole notion behind having a one-to-many relationship between Atlas and CDMs is so that you can have one cohort definition that you want to apply across all the other things. Once upon a time, it was one-to-one, and we quickly found out, like as soon as you got into this, it's like, great, I'd like to do this on 5 databases. It's like copy. It was horrible, and then the numbers didn't line up because you created number 5 over here, it became number 12 over there, and so you don't even know what's what. So this way keeps the number of the cohort the same across all of your instances. Sorry? Which library? Well, I'd have to copy it there, but right now I'm just doing this in my own local environment. Oh yeah, sure. Yeah. I'm sorry. I thought you meant like, is it gonna get there somehow? And you're asking me. Yeah, absolutely. Okay, here we go. Look at that. All right, check this out. What this is showing us is that we had 288,000 newly diagnosed people of the lymphoma. Then we got to the point where we wanted to say you didn't develop any other cancer, no other cancers. Only 55% of the people satisfied that. So this is very informative to tell you, like, what are we missing here? Like in your population, that base population, half of them did develop another type of cancer, but half of them didn't, and that's the group that we're focused on. But this is just informative. According to this, yes. And it could have been before or after the new diagnosis of lymphoma. We just said all of it, get rid of. Okay, so now we want to do the generation on the other drug cohorts, right? Which we don't really need to do in this case. So now we'll go over to pathways. And we're going to make a new pathway analysis, and we're going to call this user 30, right?
So why are you going to pathways instead of incidence?
Because we don't want to see the incidence of the treatments. We want to see the progression of the treatments through from at the time that they got newly diagnosed. What is the order of those 3 things do we see in the population? So we could do an incidence, but the incidence is looking for exactly one of those things. So, and actually this will kind of be an incidence if you think about like 45% people had it, like that is an incidence rate, so to speak. It's a proportion, it's an incidence proportion of like among newly diagnosed is how many had the one and how many had the second. But anyway, before I step in it thinking, all right, so we have our lymphoma target population. By the way, I just want to make sure that how long are we following these guys? Oh, till the end. They got diagnosed and we just are looking forever. That's fine. Just so you know. We can change it later. We could change that. Do you want to change it? We can change it. Let's change it. We're not. We're just saying, and that's an excellent point. It was brought up that it would be nice to know a person that switches the next day is going to be in the same bucket as the person that switched in the next year. And they would like to know is that if there was a way to add to the visualization, a way to say there was a delay in switch. So you know, the first ring would be you went on it. Second ring would be so many people, like how many people less than 30 days went on and how many people greater than 30 days went on. And then that next ring gets you there. And then the fourth ring would be another how long did it take to move and etc. But right now it's not about time. Right now it's about order. Like just what happened first, second, third. But you're absolutely right. It is meaningful to know somebody switched immediately versus somebody didn't. You know, somebody stayed for a little while.
That's the pain of that switch, because if that switch happened like half a year after, it could indicate that the patient had a remission and then a relapse, and that's fine. But we would like to see a quick switch, like 30 days.
Right, like a minimum duration.
30 days switch,
Yep,
right? And
yep.
then ignore the rest.
All right, so we're saying it's a fixed duration. We're going to say from the diagnosis date, we're going to go out 1 year. So remember how we talked about cohort entry, cohort exit. Our original way was saying you enter and you never leave. So whenever your observation period end date, that's the end. Now we're saying up to a year. If they ended early, they end early. But we will look up to 1 year after. If we wanted to say they have to have a year after, we would say post-observation. But for this, we'll just not do that. All right, so saving that, going back to cohort pathways. So we have that lymphoma, and then we want to import the 3 drugs. Order doesn't matter. Okay, good? Now, here's another question for you. What type of wiggle room would you want to use? Like if somebody started on day 1 something and then started on day 3 something, it's going to look like they started with this and then they went to this. If we can make it so that if you start something within the same time window, within a certain threshold, you consider them starting simultaneously. Okay, so and we call this the combination window. So the question is do you want to give it a little bit of, like, drug exposures are not exact, right? So do you want to say within 7 days, it's kind of, we'll treat them as a simultaneous start? I don't know, though. All right. We could make it 30 days? Yeah. Perfect.
What often happens is that I think it's Rituximab, right? So Rituximab is a standard of care for lymphoma.
We're about to find out.
Yeah, or I think it's Rituximab. It could be one of the others. But there's one of these molecules that's the standard of care, and that's the election on the second molecule for the combo. And that's where there's going to be a lot of change.
We're trying to make it generic.
But in the beginning, I think that they cannot assess the treatment failure quicker.
I'm going to run this.
Like after both. So
They're hypothesizing. We're going to give them an answer, and then they're going to. Here's my prediction. They're going to see the answer. They're going to be like, of course. Ah. All right. So this may take a little bit longer. As in, like maybe 5 minutes. So we can just chill. And I should probably. So you guys continue thinking. Oh. So this one was found, and then this one was found, but we didn't see anything of the third cohort. Like it didn't even happen
in this population.
in this population.
Probably got the wrong
Maybe.
or that's too new.
Well, you said Rituximab, that's the standard of care?
I think yes.
I would say yes. Well, of course, if we don't really have enough choices. So, do you want to go ahead and maybe define a couple more that might be at play.
We can work with other teams.
And
This was-
how can we work, could we define a combo?
So interestingly, it would have, if you had two exposures starting at the same time, it would have been a combo.
I see.
But nothing appeared as a combo, which is strange. So, well, maybe it's strange. You said that usually they create combos with this. But let me double check something about the definition of these cohorts to make sure that they have to be persistent, they have to be continuous exposure, not all time, because that wouldn't work. So let's see, just make sure I did this right. So end of continuous drug exposure.
You know what the reason could be with those J codes and how they're reported, right? Because
So that's true. So J codes are they usually are just like they're an injection. Yeah, they don't have a duration. So the only reason why this particular thing would work is if you got the injection, 30 days later you got another one, 30 days another one. Is it truly 30 days, or should we say something more like 90 days? 2 weeks. It's just 2 weeks. All right, then we should have had longer than 2 week durations if somebody got it more than once. So what we're saying here is that it doesn't look like there's any of these treatments were overlapping. Otherwise, we would have seen it happen. We would have seen this overlap occur. So pretty interesting, right? So I don't know if that's a artifact of the data or whatnot. You know, at this point, I would be, you know, maybe looking at the raw data to try to understand, is that really true? Is that really happening? But according to this, it's like there wasn't even a transition to the next drug according to what that did. It's just everybody started with that, and then the second drug you specified, some people tried it, a very minor percentage of it, and then that was it. They never went on. So the other thing we can do is we can look maybe a little bit longer term. Instead of stopping at a year, we can look longer, just for giggles, just to see what's up. So let's go back to here, and we're going to change this cohort to now look a little bit more. Yeah. So we're going to look at, let's say, 2 years. Say 3 years. Who cares, right? Let's just see what happens. All right, pathways, and then generate. So what I'm going to do is I'm just going to regenerate this guy. This one right here, I'm going to generate again. 2 minutes later, we'll see what happens.
So I am going to close this, go to cohort definitions. This was the cohort definition that is here. Here is the concept set. We will go to export, and there's the JSON object of the concept set. You go copy to clipboard. Now, this is the J&J instance. Let's go to the amazing AWS demos. Let's go to search, import, concept set, paste, in. There it is. Done. So you can do it for any object. You can also do it for the entire cohort definition, not just the. So this was the lymphoma cohort with all of these things. You can go here to export of the entire cohort. Go to the JSON object, copy that, go to your other instance, go to cohort definitions, new cohort, export JSON. Now you take the original one, delete it. Right, this is the default empty one. I paste the one that was in my clipboard, reload, and now I have the lymphoma cohort transformed.
Do you need to specify the information?
So every Atlas instance, when it initiates, there is a configuration page. This is where you pre-specify your connection parameters. So all the connections are already pre-specified. In this instance, there probably is 100 configurations. In this is the public instance, has 2.
All right. Yeah, it's down. The system is down. So what we're doing here is I am trying to go to, just to wrap up. We're going to do a wrap up. We're just going to like cover, and I apologize for not giving everyone, more attention. But just wanted to cover and just review what this group did with cohorts and how they tried to apply that to answer a question and a theory and like get some information, okay? So what this group did was they had a question about, after you've been newly diagnosed with lymphoma, what does it look like in the data as far as progression between treatments for lymphomas? And they didn't define many of those treatments, but they defined 3 types of drugs. Yeah, sorry. I'm zooming in and nothing is happening. But now my browser's hung. Hold on. Oh, wait. 1 second, everyone.
So how big is the Atlas team? How many people work on it?
So we have one organization called OHDSI. They have about 5 people, and then we have a few contributors from Janssen, me, myself, Anthony, and then we have Reagan Streif, and so I would say maybe like a total diverse collaborators around maybe 10. All right, so what we have here is, so this is the newly diagnosed lymphoma. Here's the 3 groups. Where was I going with this? Oh, you wanted to see bigger? Okay, that's where I was. Here we are. And the idea here is that we want to know what the treatment progression was in this population. This population was defined by starting with the lymphoma and following and like setting the end date of that cohort to be 2 years or 3 years after that diagnosis. Not everybody has 3 years, but we're just looking 3 years ahead. And we set up this combination window to basically say if we see a exposure start within 7 days of each other, then consider it a combo, or snap it together so that it will appear as a combo in our tool. However, once we generated, by going to the executions tab and taking a look at the results, so here's the run we did. We just basically kind of see the same thing. We have most people starting with this. There's oh, look, we have 1 second guy. By increasing it to 3 years, we actually picked up 1 switch. And it was a very minor one, like 0.3% of the people, like actually, for whatever reason, switched over. Right? Right?
One day you
Done.
do research, not important.
There you go. So, so that's what we did with that particular cohort. So it was a kind of an explanation. It was a combination of a base population cohort that was actually it was a diagnosis, so newly diagnosed cohort, and then it
also excluded all other cancers.
right. So we actually I'd like to show that off as well because I felt that was an important thing to maybe try. Oy, sorry, I'm zooming and it's lagging my laptop for some reason. Come on. Give it a sec. So I'll show you what that concept set looks like. So I'll go into this guy. So we said that we wanted to look at people that were diagnosed with a lymphoma but didn't have any other cancer except for the lymphoma. So the concept sets that we created were, the lymphoma concept set was a very simple one. It was just basically the concept of a malignant, lymphoid, et cetera, and all of its descendants. That was 6,400 individual SNOMED codes. And then to build our cancers without lymphoma, we basically took that concept and made that an exclusion, a code list to exclude from a higher level malignant neoplastic disease. Whereas in SNOMED, malignant neoplastic disease covers like a wide range of basic cancer. So this basically is like taking a look at a very large tree and then trimming off 1 branch that we basically are saying we want to see the people with the lymphoma, but we don't want to see any of those other drugs. Now, by excluding it from this code list isn't how you excluded the people. We just needed to get the right code list together to positively identify those people to exclude. So if you had 1 occurrence of any of these codes, you are out. And to show you that, we have this no other cancer rule that basically says exactly 0 of a condition diagnosis of any cancer that's not lymphoma. Anytime before or after. because we don't mind looking in the future. We're really trying to just isolate the population to those people that never develop those other cancers. And to look back at the results real quick, I'm like wondering how many people that actually is. Let's go back to here. That turned out to be, so this is interesting. There was 159,000 people in that cohort, but only 6,800 of those people, which is 4.3%, are represented in this pathway, meaning that there are like 95% of the people didn't even get one of the treatments that you talked about. So why don't we do one last thing, if you all are willing, we'll start a characterization, because we want to know what it is that those people are, this is going to be a treatment of, like, baseline treatment, so I'm sorry, I'm not going to be able to, what I'd have to do is basically look at these people, but then try to find an index, like a start date that's way in the future, and then look behind that to get this characterization. When we do characterization, we're looking at time at the start of the cohort and prior. But our question is if they weren't taking those two things, what the hell were they taking? And we're trying to look at the during exposure period of time, which is just a more complicated way to formulate the cohort, which we will not have time to do right now. Sorry, because it'll just be a lot of confusing stuff. But anyway, what you would want to do is you take that baseline population and you run a cohort characterization of future time. Right now, Atlas supports only backwards time of characterization. But what we want, and now that we're talking about it, it's actually probably a good feature to have, to be able to specify a time window ahead of the index date for characterization. But right now, the focus is characterization at baseline, not characterization in the future. Until this particular use case, I actually didn't think future characterization would make sense, but it sure does. Oh, damn it, you and your house utilization. Okay, so guys, I just want to thank you all for your time. Because it's after 5, and it was, we ran long. We will be sending out slides. I will have my email address in it and all the other faculty as well. And then you guys can make contact with us and tell us about your adventures in cohort definition building. And if you have any questions, of course, going to forums.odyssey.org is a great way to reach out and make contact. All right?
Thank you so much.
All right, guys.